Hi guys, so now I'll tell you a Python program to multiply two numbers and uh, how it works inside a computer. So x is equals to 2, y is equals to 5. Now print x into y. This is what we want to print. I'll run it and you'll see the 10 is there. Now, once you're writing this, how it happens inside a computer. So this is the your source code. Source code. Now the interpreter takes your source code, interprets the source code and converts your source code into machine language. Machine language, which is 0 and 1 binary digit. In between, it's first converted into assembly language and then it's converted into machine language. So, this is what a assembly language or something looks like. So these are the things. Uh, these are the. Okay, wait. I'll show you. So this is what a machine language, assembly language looks like. Then it is all these things. For example, the assembly language is 105 and 05. So this is what a assembly language is. Then it's converted to binary language like this. So we don't understand what is written here, but this is actually x is equals to 2, y equals to 5, and all those things converted into binary. Something will looks like this. So you cannot write this. So this is what a machine will understand. Now this is the code that 0110 binary things is being converted. Now the machine thinks. Now this code which is written is does not directly go to save. It's stored somewhere like a file in a file. So that file is in which it is stored is supposedly in your HDD. It is in your HDD by your Python executable file. So here it is your Python executable file. So now this file, now this is where somewhere is the CPU. Now for CPU, now once you run this file, the CPU will perform all the tasks that is written inside your computer. So there is a huge gap here, which is like a processes which take place for your Python file and your CPU to execute your Python file. So firstly, your Python file secondary memory, it's being sent to the SSD. Now this file is being sent to SSD, and then the SSD, all these things, the travel between all these things is being done with address bus slash data bus. So these are what system buses, system bus. Now all these transfer takes place, and here is your final main memory. Main memory. Now this file is stored here in your RAM. RAM is what your main memory is. So so everything is storing in RAM and everything is storing in RAM. So RAM doesn't get filled and all. It does, but once you turn off your computer, everything in the RAM gets flushed out, but everything inside your HDD or SSD doesn't get flushed out. So RAM is like a temporary storage for your execution cycle or instruction cycle to take place. So once the file reaches the uh, main memory, that is RAM, the instruction cycle between your RAM and your CPU takes place. Now, what this instruction cycle is, I'll show you with a picture of it. So, this is the picture of an instruction cycle or something like a RAM. Now, this is this is what your CPU is. This is what your main memory is. Okay, so I'll just make it again. I'll just now here. This is your main memory. This is your CPU. These are registers. What these registers do is these registers store the temporary address or temporary data for your uh, which comes from your RAM. So first step is x is equals to 2. Second, what we have written in the file is y equals to 5, and then print x into y. So this was the Python. Now this is in 0 1 format. I have written it in not in that format. Now this is what is written here. Now here is your control unit and a decoder which converts the processes for the CPU to understand. Here are the addresses of each thing in your file. Now, the first thing is in the first register, it stores the address of the next thing that has to be executed. This address is being passed to here MAR. Then this address is being sent and stored here, like now, stored at where the address was. Now, what happens is we want to know what this address stores or whatever the data is there in the address. So CPU sends a read command. It reads the address which is being sent by this MAR and see whatever the data is written here. The data is being sent via system bus or data bus, and see here we have written x is equals to 2. So there's nothing that has to be performed by ALU. So 2 is being stored here. Now second thing y, the address of y, then the address is passed here, then the read command is being passed and the here then y is equals to 5, and यहाँ पे y is equals to 5 is stored here. Now the third thing, print x into y. Now the CPU takes the read command, address stored, then the address is stored here, then the read command takes the CPU takes the read command, and the read command what it does is it takes the data inside that address and pass it via data bus, and see here it is written x into y. Now this is what the CPU has to perform action. Now it is being sent to the decoder or the control unit. Now the control unit have x into y to perform. Now x is passed here, y is being sent here. Now 2 into 5 is performed under the ALU and 10 is there. Now this is what is written here. Now your CPU is having the 10 as the in 0 and 1 format. Now this 10 is there. Now this 10 has to be sent to the back to the display where you have performed the your Python where you have run your Python executable file. Now this is being sent via signals which is being in the way it is being converted from analog to digital. Now these are the converters that are there present in the input output devices or see, input devices, what it does is, what are input devices? I press the key of a keyboard, I press the mouse button. So these are the input devices that I give command. Input devices are the devices which give command to the computer. Now, input devices have these digital things or the digital signals, which is being converted into analog signals. So digital signals are those signals which we can understand, like clicking of a mouse, pressing of a key are the digital signals. Analog signals are the signals which the machine, computer can understand, or the 0 1 or the binary code or the binary language. So this is what is being converted by input devices. Once press something, those signals are converted. Now, once those signals are converted, the output of these all these things come. Now, while the output devices like display or secondary display or anything shows these things, before that it has to be again converted from analog to digital. Analog is what the 0 1 format. Digital is what supposedly your display, you want an image, you click on an image, double click on an image, and then image is being shown to you. Now that is being, firstly that double click signals has been converted, the execution command has been done, the process is done, and then when the output is being shown to you, the image, it is being converted from your analog signal to digital. So the GPU and all these things takes every pixel of that image and then they show it to you on your display. So right now the output is 10. Now 0 and 1 analog to digital conversion takes place, and then all these things are being shown to your display. Now GPU takes part in this because all the things that has to be performed are like that. Whatever you're gonna be see on your display is because of your GPU, because the GPU performs tasks just like CPU, but it performs tasks just those tasks which are related to like image showing display, or colors in your display, or anything diagram that you make on your display is being shown to you via GPU. The GPU takes part in that, and through that the 10 is being shown to you. Now this is being shown to you, all these commands are done. Now these all these things takes in like a very less seconds, or like very less time, all these things takes place. So once you do this, x equals to 2, y equals to 5 in print, then it is being shown to you. Before that, the interpreter takes everything, the executable Python executable file into main memory, then a secondary memory, then it's sent to main memory. Instruction cycle takes place. Instruction cycle tells the output, against converts those output from analog to digital, and then shows it on your display. All the display things has been given to you or shown to you via GPU, because GPU takes place of those things which likes the display, like the color here is yellow, here is white, all these display and everything that you're seeing or picture you're seeing is the GPU which is controlling all those things. So now let's just again take another example of 10, and let's say x slash y. Now what it does is it gives us a string of 2.2. Now this is a program for division in which we divide to number. So the everything remains same, just the commands and everything is changed in your. So the ALU which performs earlier, which was performing the multiplication of two numbers, is gonna be performing the division of two numbers. Now you see, this is what a supposedly this file we have saved it. Now this file is stored in your disk. Like here, it is stored in your disk, and this is your main memory. This is your display. This is your USB. So you give signals. It is being converted into analog signals. Then the Python executable file, the interpreter converts everything, like the compilation and in conversion of your source code into your machine code, like 01, is being done inside the interpreter in a Python file. And then the Python executable file supposedly is here, like in the disk. Now you want to run this file. Now this once you run this file, what happens is you save this file in the disk. Now this is your disk, like HDD supposedly. Now this disk will not directly go to your CPU. It will first pass the hello world or the hello file to your main memory. Then main memory uh, perform the task with your CPU and the main memory in between that. So let's just go again. So main memory, I think now by now you'll be able to remember how the CPU and instruction cycle or everything takes place. So also I'll tell you one thing. Right now I have saved this file. Okay. So if I'll say x into y and I run this. Okay. So this is also x plus y. Okay. Now run this. This is all these things plus minus y. All these things are same. It's just that all these things are performing inside your CPU, and everything that is being performed here inside the CPU, ALU performs all these tasks. How does the file reach till ALU and everything? That is what we just saw. So once the file reach the RAM, how the file reach the RAM? The file is being stored in your disk HDD. Then this from here it is sent to your main memory via this system buses takes place. Now once here the file reached here, hello file. Now in the RAM the hello file is there. First command x is equals to 10, second command y equals to 5, then print. x slash y. Now here the conversion of things takes place between them. Now you could see in the picture, this is the CPU, this is the ALU, these are the registers it stores like the temporary address or the temporary data. Now, this is the program counter, this is the bus interface. What it does is all these program counter PC bus interface. So, PC is what it stores the output, temporarily stores the output of anything. So, these are the input output devices. This is the display in which you're able to see the output of your screen. Now, here is the visual representation. So, firstly, wait, I'll just make it to you right now. It's of yeah. So this is your CPU, temporary registers, ALU, okay, PC. Now this is what your control unit is. Inside it has a decoder. Now X is equals to 10. What it does is it first takes the address of this command, stores it here. Address supposedly address is 10001. So it stores 10001 here. It's passed here 10001. This is address. Now CPU sends a read statement, read command, what is written at 10001. So this data now at 10001 is what your data x is equals to 10 is stored. So it is being sent at this register the data inside 1001 address. What is the data inside is x equals to 10. Now x is equals to 10 is being written here. Do we have to perform any task? Is there any need of ALU? No. And it just stored the output of this as x is equals to 10 here. Now second thing in the file, then the address is like 1002. Now 1002 is written here like in CPU and this register 1002. Now it is being passed here like 1002. Uh, Control unit sends a read command or the CPU sends a read command. What is written at 1002? Now what is written is y is equals to 5. Now the data inside this is sent via data bus. Now this is this what is stored in. Now the data is being sent here. Now this is the ALU. Do we have to perform anything? Instruction no. Then the here y is equals to 5 is stored. Now the third instructions. What is it is 1003 address supposedly what is written? Print x slash y. Now what is do we have to print? Now the address of it 1003 and it's passed here 1003. Now at this address read command is being sent. Now what is the data written here is x slash y we have to print. Now there is a command that has to be executed. So the control unit or decoder performs this task. X is equals to y. Here is x is equals to 10, y is equals to 5 is written ALU. Now ALU. Okay. Then this is the x slash 5. Now x is equals to y equals to 10, 5 x is equals to 10 is being sent to the ALU. Now inside the ALU we have x which is 10, y which is 5. Now the decoder here, what it does is decoder sends the execution command that we have to divide these numbers. And here is the PC. Now after division we comes with 2. So the PC stores the value of 2. Now again CPU, everything is done, everything, all the registers are empty now. It's just that the PC have the value 2 in the 01 format. Sends it here. Now from here, it is being executed and it in your display it is being shown. Now the commands is being converted from analog, which is what is an analog language? It is what 01 format is being converted to digital language or digital signal. Digital signals are what? What we understand as humans. Now on your display, we are able to see 10, which is the, or sorry, on display you'll be able to see 2, which is the output when you run the Python executable file. So this is what uh, a program for division of two numbers, how it happens inside a computer. So yeah, this is what we know now. We know how a Python program runs inside a computer.